Hi guys, welcome back. Today a group of farmers we are here to explain you about the Verilog code to implement 2's complement of a number. Myself Hemant Goda MP, currently studying Sri Venkateshwara College of Engineering. Now my part is introduction. The project focuses on the implementation of Verilog code to compute the 2's complement of a given number. The 2's complement is a fundamental operation in digital design and is extensively used in various applications, including arithmetic operations in processors, signal processing, and communication systems. Significance of the project. Subtopic is digital arithmetic. Understanding and implementing the two's complement in Verilog is crucial for digital arithmetic operations. It forms the basis of subtraction and is integral of the representation of negative numbers in a binary. The second subtopic is processor design. In processor design, arithmetic and logic units ALUs use the two's complement to perform signed arithmetic operations efficiently. This project contributes to the foundational knowledge required in processors arithmetic. Thirdly, we are going to see the data representation. The two's complement is widely employed for a representing signed integer in computers. Mastery of this concept is essential for digital designers working with data representation and manipulation. Error detection and correction. The two's complement is often used in error detection and correction algorithms. A deep understanding of its implementations is crucial for designing robots and reliable systems. Next, we are going to see about the educational significance. For students and learners in the field of design, digital design and Verilog programming, this project serves as an educational tool, providing hands-on experience in coding and simulating a fundamental digital logic operation. Bridge to advanced concept. Mastery of the two's complement operation serves as a stepping stone to more advanced concepts in digital design, such as floating point arithmetic, digital signal processing, and hardware description languages. In this project, significance lies in this foundational role in digital design. Its application in various fields and its educational value for individual aspiring to deepen their complement not only addresses immediate computational needs but also lays the groundwork for more digital applications and designs. Objectives. First objective is implement two's complement logic. Develop a Verilog code module to accurately perform the two's complement operation on a binary number. Ensure correctness and efficiency in handling both positive and negative input values. Second objective is support for various input sizes. Design the Verilog code to adaptable to different input sizes, providing flexibility for integration into diverse digital system. Considerations and should be made for scalability and ease of use. Third objective is optimize for resource utilization. Optimize the Verilog code to minimize the resource utilization while maintaining the functionality. This involves efficient usage of hardware resources, ensuring the code is suitable for implementation on field programmable gate arrays or application specific integrated circuits. Simulation and verification. Conduct through simulation and verification tests to validate the correctness and robustness of those complement implementation. Utilize the Verilog implementation tools of analyze wave perform outputs and confirm adherence and expected behavior. Fifth objective is documentation and readability. Provide a clear, comprehensive documentation for the Verilog code, including inline comments, module descriptions, and any necessary expansions. Prioritize code readability to facilitate understanding and future modifications. Sixth objective is educational value. Serve as an educational resource for individual learning Verilog on digital design concepts. The code should be structured to enhance understanding of the two's complement operation and its applications in digital system. Seventh objective is application in digital arithmetic. Ensure the Verilog implementation aligns with the standard digital arithmetic principles as the two's complement operation is a fundamental component in arithmetic circuits. Verify its sustainability for integration into larger digital system. Eighth objective is real-world Appl- Impasse is the real world applicability of the Verilog code by highlighting its significance in processor design, data representation, and error detection correction mechanisms. Connect the project to practical scenarios where the two's complement is commonly employed. Ninth object is encourage code reusability. Design the Verilog module with an emphasis of modularity and reusability. This facilitates its integration into different projects and environments, promoting a versatile and adaptable implementation. The last object is presentation of results. Clearly present simulation results and analysis in the documentation. Discuss any challenges faced during the implementation and how they were overcome, summarize the outcomes, and evaluate the overall success of the Verilog code for those complement. Now I'm hand over to my friend Krishna Teja Reddy. Control Endo.
Hello everyone, I am A. Krishna Teja Reddy, second year CSE student studying in Sri Venkateshwara College of Engineering, Bangalore. Today I came with the Verilog code of 2's complement of a number. You can see the following code. Module 2's complement, input sign 7 is to 0 number, output rec sign 2's complement, always begin 2's complement. This is the code. Now I am going to stimulate it. Select, compile, compile all. The code is successfully compiled. Now we'll go to the library work, open the 2's complement of a number. This is the objectives we'll add to where it has been added. Now we have to give a clock to this 100. Okay. For second we have to give 200. Like that only we have to multiple for all numbers. Now we can see the following output. Explanation of the design consideration, input and output size. The model takes a 8-bit signed input number to present both positive and negative values. The output is also an 8-bit signed number to maintain consistency with the input size. Signed data type. The use of signed data type is in a Verilog is crucial for handling signed numbers, allowing for proper representation of negative values. This ensures compatibility with the real-world application where the 2's complement is commonly used for signed arithmetic. Un- Unary minus operation, the implementation utilization of the unary minus operation in Verilog for simplification and reliability. The operation performs the 2's complement operation by navigating each bit of the input. The Verilog compiler interrupts the minus as the 2's operation when applied to a signed number. Always block. The 2's complement operation is placed within any always block, which means it is automatically triggered wherever there is a chance in the input. This design choice ensures that the output is continuously uploaded based on the input changes. Blocking assignment. The blocking assignment is used for the output assignment within the always block, since the two's complement of a number is simple operation and does not involve complex sequential logic. Blocking assignments are appropriate for the scenario. Readability and simplicity. The code is designed with an emphasis on readability and simplicity. The use of standard Verilog constructs and syntax aids is understanding and integration into larger digital designs. Clear and meaningful variable names such as number, two's complement enhances code comprehension. Parameterization. While the code is specific to an 8-bit implementation, it can easily be adapted for different bit widths by adjusting the bit range in the input and output declaration. The parameterization enhances code reusability. Test bench integration. This module can be easily integrated into a test bench for simulation and verification. Test can be performed with various positive and negative input values to ensure the correctness of the two's complement operation. By considering these design aspects, the Verilog code offers a straightforward and effective implementation of two's complement operation suitable for integration into digital design request signing arithmetic. Now it will be continued by my friend Bharat M.
Hello, myself Bharatham. I am present in the topic methodology. First one, understanding the requirements. Clearly define the specification of Verilog code. Understand the input and output requirements, bit width, and any construction related to implementation. Second point is literature review. Familiarize yourself with the concept of seconds, compile and its significance in digital design. Refer to relevant textbooks, online sources, and documentation to be build solid theoretical foundation. Third topic, Verilog environment setup. Set up your Verilog development environment, ensuring that you have access to Verilog simulation and Verilog synthesis tool if you plan implement the code and hardware. Verilog code design. The design Verilog code implementation of second compile consider input and output sizes, use of same data types, and any potential design parameters for scalability. Code review. Construct a true viewing of your Verilog code. Ensure that it addresses to best coding practice. Usual comment for readability for following model structure. Simulation and verification. Develop a test bench to simulate and verify fundamentals of your Verilog code. Text various sensors, include a positive and negative input values, boundary cases, concurrent cases. Debugging. Identify the address of any issues or bugs and arise during the simulation. Utilize debug tools provide Verilog code simulation to trace and rectify problems in the code. Performance optimization. Optimize your Verilog code for resource utilization and efficiency. Consideration any include minimization hardware resources and ensuring speed of seconds compile operations. Documentation. Create comparative documents for your Verilog code. Include a project review. Objectives, design, consider a code explanation and any other relevant information document should be clear and concise. Both understanding the potential future modification. Test bench enhancement. Expand and refine your text bench to cover a broad range of test cases. Ensure it is truly validates the correctness of your Verilog code, understand the various conditions. Hardware implementation. Applicable consider synthesizing your Verilog code for implementation on hardware. Ensure that your code meets hardware contains performance requirements. Result analysis. Analyze the simulation result, hardware implementation outcomes, assess the performance, corrections, and efficiency of your second compile implementation. Report writing. Prepare a comprehensive report summarizing your mini project, include sections on introduction, objectives, Verilog code, design, simulation result, challenge phase, and future works. Follow any specific guidelines provided by inductor or instruction. Presentation. If required, prepare a presentation of the communicate your project findings, methodology, and outcomes. Highlight key excepts your Verilog implementation, address any question for feedback. Pre-review optimization. Share your Verilog code documentation with the prepare mentors of feedback. Incorporate constructive suggestions to improve the quality, roundabouts of implementation.
Hello everyone, I am Charan. Now I am going to read a result of this topic. Correctness and implementation. Evaluate whether your vlogging code product a current result for the second complement operation. Ensure it handles both positive and negative input number correctly. Simulation result. Analyze the simulation result obtained from the test bed. Check your expected waveform and verify and the second complement of computed accurately for a variety of input values. Code efficiency. Assess the efficiency of your vlog code in terms of resource and utilization. Evaluate whether the implementation is optimized for hardware constraint and whether it uses the resources efficiently. Scalability. Test the code with a different input size to ensure its scalability. If your implementation is designed for an 8-bit number, check it if it can easily adapt to the another bit widely without a significant modification. Documentation quality. Evaluate the clarity and completeness of and documentation. Ensure that your report cover all necessary aspects, including an instruction object, vlog code, explanation, simulation result, and any challenges faced. Educational value. Consider the education value of your project. If the code is meant for an educational purpose, assess whether it efficiently communicates and contents with and to complement and simulate for learners. So, the test code hunter variants include a edge case and unusual inputs. Verify that the handled unexpected situation carefully and does not produce an error expected result. Code readability. Assess the readability of your vlog code. Ensure the variable name, comments, and overall structure contribute to the code clearly. A well commented and easily understandable code is valuable for an com- collaboration future maintenance potential for hardware implementation. If you plan to implement a code on a hardware, evaluate its sustainability, ensure that it meets an hardware content and it perform aligns with the project requirements. Presentation and communication. If you are required to give a presentation, evaluation your ability to efficiently communicate a key aspect of your project. This includes explanation the program and solution of handling questions or feedback. Now conclusion is going to explain my friend is going to explain conclusion.
Now I am going to conclude this topic. Conclusion. The minimum project I meant to design and implement a Verilog code for a computing 2-second compile of binary number. project objectives were successfully achieved, and there is implementation demonstrated proficiency of in digital designing principle. Verilog performance a practical application of second complication operations that following key conclusion be drawn from the mini project. Successful implementation. The Verilog code effectively computes the second compile of the 8 bits significant through the region. Testing and simulation. Implementation has been validated with the range of input values. Scalable and adaptability. The implementation exhibits scalability, allows the easy adoption and different input size. The use of same data type ensures the variability code, handling both positive and negative numbers. Efficiency resource utilization. The Verilog code is designed with the emphasis on efficiency resources utilization through optimization. Implementation minimizes hardware resources using the while maintaining high level functionality. Educational value. The project serves an educational tool providing a clear and concise example. Seconds, compiling implementation Verilog code. The code documentation structure contribute its suitable learners find of digital design. Readability and documentation. The Verilog code readability with meaningful Verilog full names, comments, and well-structured format. Documentation offers a overview, understanding the potential feature and demonstration. Simulation testing region. The regional simulation testing were conducted over various sensors and edge cases. The project's successful handling different acute results ensure reliability, real world applicability. The implementation showcases the real world applicability of seconds compile operation practical series were signed automatic arithmetic essential such as process design, data representation, error detection, correction mechanism. Future consideration. While the current implementations meet the project objectives, there is a potential future enhancement. This may be conclude future optimization, additional features, and integrating into the more complex digital systems. In conclusion, in Verilog code implementation, second compile number and successful meet up the object providing values contributing digital design, understanding the project, emphasis corrections, efficiency, educational value, position, solid for foundation, future explanation, application, digital design contexts.
Thank
Thank
you
you.
for watching this
Watching our
video.
videos.
Please like this video. Bye. Tata.